Here is a mistake I have watched developers make more than once when building their first Kotlin Multiplatform app. They copy the pattern they know from Android, create a new Ktor HTTP client inside each repository class, and ship it. On Android, it works fine in testing. Then they run it on iOS in production. Within minutes, the app starts throwing mysterious socket errors. The reason is that Darwin's URLSession, which is the engine Ktor uses on iOS, holds an operating system file descriptor open for each client instance. iOS imposes a per-process limit of around 256 file descriptors. 10 repositories, each cycling through requests, and you are burning through that budget fast. The fix is simple but has to be deliberate. One shared HTTP client for the entire app, created once, injected everywhere via dependency injection. In this episode, you will see exactly how the MyEuroStatApp project enforces that discipline, and you will understand every configuration line that makes it work on both Android and iOS. Koin is JetBrains multi-platform HTTP client library. It is not a framework like Retrofit. Retrofit generates implementations from annotated interfaces at compile time and is tied to the JVM. Ktor is a builder-based coroutine native client that compiles to every Kotlin target. The architecture is intentionally split. A platform-agnostic core in common code defines the configuration, the plugin system, and the coroutine integration. Then a platform-specific engine underneath actually makes the TCP connections. On Android, that engine is OkHttp, the same battle-tested library Android developers have used for years. On iOS, it is Darwin, a thin Kotlin wrapper around Apple's URLSession framework. You write your HTTP logic once in commonMain. The engine swap is invisible to your feature code. That is the exact pattern this project uses, and the rest of this episode is the code tour that proves it works. The bridge between common code and platform engines is a single expect function. Open the file at core network commonMain EurostatApp client.xdh. Near line 65 you will find this declaration: expect fun, create HTTP client engine returning an HTTP client, HTTP client, HTTP client, HTTP forced contract. The expect keyword tells a Kotlin compiler that this function must be fulfilled by every platform target that includes this module. There is no default implementation. You cannot ship without it. Now look at Android main HTTP client engine.android.xttp, client engine.android.xttp, client house main HTTP client HTTP. Open iOS main HTTP client xttp.house main HTTP client e.xtt. One line, actual fun, create HTTP client engine returns Darwin. Same signature, same package name, different bodies. If you add a new target, say a desktop JVM target, and you forget to write the build fails before any code runs. That is the guarantee compile time safety for platform divergence. With the engine contract in place, the shared factory function createHTTP client can build the client entirely in common code. It calls HTTP client and passes the result of createHTTP client engine as the first argument. The first setting it applies is expect success equals true. Without that flag, Ktor returns the HTTP response regardless of status code. A 500 error from the Eurostat server would come back as a normal response object. With the flag, any non-200x response throws a client request exception or server response exception, which the repository then maps to a typed app error. The second setting is default request. The base URL for all Eurostat API calls is set once here. Every relative call from any feature module like HTTP client.get of the dataset code resolves against this base. No string concatenation in feature code. No risk of a typo in a URL that appears in 12 different files. The Content Negotiation plugin is installed next. It is given the shared JSON configuration, which handles deserializing the response body from JSON into Kotlin data classes. Without it, you would have to call body as string and deserialize manually on every request. With it, you write body as JSON stat response and Ktor does the rest. Then HTTP timeout is installed with three values: request timeout millis of 30,000, connect timeout millis of 10,000, and socket timeout millis of 30,000. Why 30 seconds? Because Eurostat is a government API. Large datasets, particularly environment and economy tables with decades of data across 27 countries, can take 15 to 20 seconds to return. A 10-second default would trigger false failures constantly. The connect timeout is tighter at 10 seconds because connection failures tend to be fast and retrying quickly is the right behavior there. These numbers came from live testing against the real API, not guesswork. The HttpRequestRetry plugin adds automatic retry behavior for server errors. The configuration calls retry on server errors with a max retries of 2, combined with exponential delay using a base of 2.0 and a maximum delay of 5000 milliseconds. Server errors, meaning 500 range responses, will be retried up to twice, with waits of roughly 2 seconds, then 4 seconds before giving up. Client errors, 400 range responses, are not retried. That is correct behavior. If the server told you the request was bad, sending it again is not going to help. The logging plugin is conditionally installed based on a debug boolean parameter. In production, it is omitted entirely. In debug builds, it logs at the headers level, which prints request and response headers to the console. This lets you copy the exact URL Ktor sent, paste it in a browser, and verify the raw JSON response, which is invaluable when diagnosing Eurostat filter parameter issues. The EurostatJson object is the Kotlin's serialization JSON instance shared across the entire app. It has 3 flags. The first is ignore unknown keys set to true. The Eurostat API is a live government service. It occasionally adds new fields to responses without announcement. If you left this false, which is the Kotlin's serialization default, any new field in a server response would throw a serialization exception and crash the parser. Setting it true means the deserializer silently skips fields it does not know about. The second flag is coerce input values set to true. When a JSON field is null, but the Kotlin property is non-nullable with a default, the deserializer uses the default rather than throwing. The third is explicit null set to false, which tells the serializer to skip null fields when encoding. This is a read-only client, so encoding rarely happens, but it is the safe default for any API client. The EurostatApp client class wraps the raw HTTP clients and the JSON stat parser. Its single public method is fetchDataset, which takes a dataset code string and an optional filters map from dimension name to a list of values. The Eurostat query URL format is unusual. Dimension filters are expressed as repeated query parameters, not a comma-separated list. A request for Poland and Germany in years 2020 and 2021 looks like $geo equals PL, $geo equals DE, $time equals 2020, $time equals 2021. Most URL builder libraries collapse repeated parameters into the last value. Core does not. When you call the parameter function multiple times with the same key, it appends a separate parameter each time. The nested loop in fetchDataset for each dimension, then for each value in that dimension, generates exactly this format. The raw response comes back as a JSON stat response and is immediately handed to the parser. The design question is, who owns the HTTP client? In this project, the answer is the Koin dependency injection container. A single module in core network creates the HTTP client as a singleton. Every feature module's API service receives the same client instance via constructor injection. Feature modules never call create HTTP client themselves. They declare the dependency on HTTP client in the Koin module, and Koin resolves it to the shared singleton. This is the only arrangement that guarantees the file descriptor constraint discussed at the start. If each feature module created its own client, you would be back to the iOS file descriptor problem. There is a subtlety here. HTTP client is safe to share across coroutines. Cold's client is thread safe by design, and the underlying OkHttp and Darwin engines maintain their own internal connection pools that handle concurrent requests without coordination code in your application layer. The API client throws on errors. The repository catches and maps. This is the correct division of responsibility. EurostatApp client does not know what an app error is. It should not. It is an infrastructure class. The domain layer should not know about co-exception types. That is what the toAppError extension function handles, which lives in core indark alongside the client. It inspects the code throwable. A client request exception with status 404 becomes app error HTTP error. A network level connect exception becomes app error no network. A serialization exception from the parcel becomes app error.parseError. Anything else becomes app error.unknown wrapping the original throwable. The repository calls sayFetch in commonMain, which catches all throwable except cancellation exception, runs to app error, and emits the result into the flow. This separation means you can write unit tests for the repository with a fake API service that throws plain runtime exceptions, and the mapping still works correctly. To see this working in the actual app, enable the debug flag when building. In the Koin module for core in-network, the create HTTP client call passes debug equals build config.config. Run the app, navigate to the population tab, and watch the Android Studio Logcat. You will see core printing the request URL including the repeated geo and time parameters, and the content type and content length of the response. Copy that URL, strip the format and length parameters, paste it into a browser. The JSON stat response loads. The value field is the flat numeric array. The dimension field is the category map. You can trace every field through the parcel code in episode 5 of this series and watch it transform into the demographic pyramid on screen. That is the full path, a platform-specific engine, a shared client, one HTTP call, the JSON stat parcel, and a composed canvas chart. Here is what to carry away from this episode. The expect and actual keywords and force engine selection at compile time. You cannot ship a new platform target without providing an engine implementation, and the build failure makes that immediately clear. One singleton HTTP client prevents the file descriptor leak on iOS, eliminates redundant connection pools, and gives you a single place to tune timeouts and retry behavior for all features. The plugin system, ContentNegotiation, HttP timeout, HttpRequestRetry, logging, layers behavior without changing the call site, and the JSON configuration with ignore unknown keys, chorus input values, and explicit nulls gives you a resilient deserializer for an API you do not control. In the next episode, we parse the JSON stat format that Eurostat actually returns. The link to the full MyEuroStatApp repository is in the description. Subscribe for more on Android and Kotlin multi-platform development, and I will see you in the next one.